Just as with sine and cos, we can also define the graph of tan. The process for defining tan, though, remember, was a little bit different to sine and cos. Instead of looking at the coordinates of this point here, and knowing that they're sine and cos, we extended the radius of the unit circle until it touched the tangent. And tan was defined as the y-coordinate of this point. Okay, the x-coordinate is always going to be 1, but the y-coordinate will vary depending on where this radius, this extension, hits the tangent. Okay, so as with the others, we can think about when it's positive and negative. It's positive in this first quadrant. We find that it's undefined at this point because that line will never cut this tangent. But if we go past, we extend back down again, we get negative values in the second quadrant. They become positive in the third, and then they've got a point of we're undefined again here, and then we flip back to negative again and continue the cycle. So let's look at how that will affect the graph. So if I show my point here, okay, again, remember the point is taking its coordinates from the angle. So here, for example, at pi on 4, its x-coordinate is pi on 4. The distance along this edge of the triangle, this distance here, the y-coordinate of this point is going to be 1, which is why this has a height of 1. So let's have a look. I'll turn that trace on for that point, and we can have a look at the graph. So it goes up like this. It's got to become negative, and after it goes past this point, it flips around and comes back up again. It's 0 just here, and it continues up. Again, flips back to negative and comes up. I'll draw the full graph of tan in here so that we can see properly what's happening. And again, I put it on the wrong set of axes. There we go. So we can see here that this is the curve of tan. And you'll notice that it's actually got some asymptotes. It's got vertical asymptotes. And those vertical asymptotes have happened at the places where tan was undefined, where these two lines would be parallel. So at pi on 2, and then again when we went around to 3 pi on 2, if we were able to continue those, we'd get one at 5 pi on 2 and 7 pi on 2 and so on. So it's worth noting, but this here on the right hand side is the graph of y equals tan x.